that means. Okay.
Keep going, don't worry.
So the presentation is intended for club members of any club who are interested in learning more about brakes and how they work, how they're maintained, and how they're repaired. And even if you decide never to do them yourselves, at least you have a basic understanding of them, so that when you're dealing with a mechanic and they talk to you, you have some concept of what they're telling you here. Now, we're going to give you all the guidance in the world, but at the end of the day, you're working on your car at your own risk. We can't take responsibility for that. And we'll talk a little bit about safety and risks along the way there. Millions of do-it-yourselfers do this every year. Besides oil changes, it's probably the second most common maintenance item on a car, most frequent. And you can go to any car parts store and they'll sell you all the hardware in the world to do your own brakes. So, you know, it's done every year, but that sometimes people do a poor job and they may hurt themselves or they may damage their car in the process. So we're going to talk, I'll talk a little bit about me and my background. We're going to talk about how do brakes work, and how does a parking brake work. We're going to get into some key inspections and warning signs that your brakes are about to fail. And then when it comes time to doing brake work, we'll talk about what choices do I have in terms of parts. We'll talk a little bit about safe practices when you're working on brakes. I'm big on that. We're going to go through a basic brake job on a car. Some of you may decide to take your car out on a track, closed track for a club race or time trials or something like that. We'll talk a little bit about what you need to do to get ready for that, because you're putting severe stress on your brakes in that situation. We got a few advanced topics. We're going to get into anti-lock brakes. We're going to talk about working on old rusty brake systems. And we're going to talk a little bit about inboard brakes, which are common on some of the Alfa Romeos that club members have here. So, at any rate, let's do a little bit about me. I live in Moon Township, Pennsylvania. I'm about 10 minutes from the Pittsburgh International Airport. Happily married with 3 adult children. My daughter's not here today with us. Member of a number of local clubs in the Pittsburgh area. I work for Covestro, which is a spinoff of Bayer. We're a German-based global manufacturer, globally headquartered in Germany, but U.S. headquarters here in Pittsburgh, Pennsylvania. We manufacture plastics and polymers. We have 35 factories around the world, and we're a major supplier to the automotive industry. So in your car, I can probably point to multiple components that probably came from us as a resin manufacturer. I lead a department that's involved in manufacturing and supply chain operations. I've led numerous projects over the years on operational improvements, maintenance and reliability in our facilities, hands-on training on how to troubleshoot in a manufacturing situation. And I've also done global workshops on improving how we manage safety at our plants. And you'll hear this repeatedly. I'm big on safety. At the end of the day, we don't want people hurt or injured or even worse, killed as a result of their cars not working correctly or hurting themselves working on the car. This is my world in manufacturing. This is a photograph of our largest plant in North America. It sits on 1,700 acres outside of Houston, Texas. We deal with big 1,500 horsepower motors, high voltage electricity, high pressure steam, high temperatures, high pressure. So again, very safety critical there. And in the world of manufacturing, maintenance and reliability is key, because every hour we're down, we lose tens of thousands of dollars in profits every hour that we're down. So, but most important, I think, is I'm passionate about cars. I'm really particularly interested in older enthusiast cars. How do we keep them on the road? How do we make sure they're safe, reliable, and fun to drive? And it all started with this green car behind me. That's a 48 MG. My father bought that. I see my sister's online when I was 5 years old and she was 3 years old, and it's been in the family ever since. So it's been in the family roughly 54 years now. I had a couple Austin Healey Bug-Eye Sprites as a teenager that I worked on. Got a Chrysler 67 wagon when I was in high school. Fiat 124. I had a 68 Fiat 124. Subaru was our first family car, my wife and I. I had a Volkswagen Rabbit in graduate school. And then I had first a mini Alfa Romeos starting in graduate school. Behind me is up on the lift is a 61 Alfa Romeo Giulietta Spider Normale. That was bought by my father in 1980, so that's been in the family for a few decades also. Had an Audi at one point, a number of BMWs. My son Alex here has several BMWs. Honda, he works for Honda. We've had a number of Honda cars. Mercedes-Benz, I've had 4 Benzes, including currently an 89 560 SL Roadster. And my wife has a Jeep Wrangler, and a Triumph. Don't own one, but my friend Mike Nicolella, who might be online, he left us with his TR7 for a few weeks, and we completely refurbished his brakes and suspension on his TR7. So let's move on and let's talk a little bit about how brakes work. So suppose you have a 4,000-pound car, which is pretty normal these days for a fully loaded luxury sedan. And let's suppose you're traveling at 75 miles per hour. All of a sudden, all the traffic in front of you comes to a complete stop, and you need to brake, and you need to brake very hard to avoid hitting somebody. In that moment, the front brake rotors can easily exceed 200 degrees Fahrenheit in this situation. So it's enough to boil water in a few seconds there as you're dumping massive amounts of heat. And if you track your car, brake temperatures can reach 800, 900 degrees Fahrenheit easily, depending on the weight and depending on the speed of your car. Any of you have watched night racing, like 24 Hours of Le Mans, you can see those rotors glowing cherry red at night. So the basic purpose of a brake system is to slow down or stop the car by converting kinetic energy into heat very quickly and getting rid of that heat as fast as possible. And so a 2,000-pound car, like some of the ones behind me, they're probably even less than 2,000 pounds, that's going to generate half the heat of a 4,000-pound car. But on the other hand, speed really matters. If you double the speed, you generate 4 times the amount of heat when you have to decelerate. So basically, brakes are thermally managing things and getting rid of that kinetic energy. So basically, there are 2 types of brake systems that have been around for quite some time here. The one on the left is the traditional one. It came around in 1902. And basically, if you look at that, you've got your foot on the pedal there. When you squeeze the pedal, you are pressing on this rod right here, and that in turn is pressing on your master cylinder. It's a piston, and you're pushing fluid to the system, and then the fluid comes to the wheel cylinders, and they exert outward force on the brake shoes. So I have on hand right here, I have a classic Alfa Romeo drum brake setup here off the car above here. So this is a classic drum brake setup. You've got what are called shoes. You have these springs right here which retract the shoes. In this case, Alfa actually has 2 wheel cylinders. They got a top and a bottom one. And so when I press on the brakes and I create that hydraulic pressure in the line, that hydraulic pressure expands those cylinders and it forces the shoes outwards. So the shoes come out radially, and then the shoes press against the brake drum. So this is a Giulietta brake drum. You got the shoes inside of here, and they're pressing outwards. And as they press outwards, that's what generates the friction, which leads you to stop the car. The other quick demo that I wanted to show you here is just kind of a little Mr. Science hydraulic demonstration here. So imagine in my hand here, my right hand, this is your master cylinder. And on the left hand, this is either your brake caliper or your wheel cylinder. So my brake pedal is here, and I'm exerting force on the brake pedal, and it's pushing the master cylinder. And if you look over here, you can see that that syringe is moving up. So I am moving fluid through the system. I got pipes going throughout the car, and I'm pushing brake fluid from my master cylinder to the corners of the car. And then when I release the brake, there's a spring on the brake pedal. It then causes this thing to go in reverse. So this retracts, it comes out, and then the wheel cylinders or the calipers release themselves. So that's kind of the fundamentals of a drum brake system. And again, they've been around since over 100 years now. On the right-hand side, or left-hand side, sorry, this is a classic hydraulic brake system. So over here, you've got the same concept. You've got the pedal. It's pushing against a master cylinder. It's pushing fluid out to the corners of the car to calipers. Now, in this case, we have a different action here. You have a brake disc at the corner, or brake rotor they're called, and you have brake shoes. And so, or excuse me, brake pads. Shoes are on drums, pads are on disc systems. So you have these brake pads right here that are seated against your rotors, and you have calipers that squeeze it. So just imagine the fingers on your hand. When you exert the hydraulic pressure, you're squeezing here and you're pressing those pads against the rotors. And the harder you push on that brake, the firmer the clamping force, and you're clamping those pads tighter and tighter. So this is this is off a 95 BMW 3 Series. It's what's known as a solid disc right here. There's no ventilation in it or anything, pretty standard for many, many decades. And I'm going to just turn the floor over to Alex here, who's going to show you some newer brake rotors off of some high performance BMW M cars.
So these are off of my M3. Can you grab that? This one, for a size comparison, you can see it just is in a completely different realm of size. So basically, the idea of all these holes and everything, and this center section, which is kind of separated from where it connects to the wheel, is to keep as much heat in this section of the brake and dissipating out, and as much heat away from the hub of the car and everything else in the car that can't get as hot. So that's why they've gotten so much bigger with heavier, faster cars, and why they end up looking like this in the end. And then one more. This is kind of an aftermarket solution to the same sort of problem, a little bit smaller for my 88 BMW. But you can get these for some cars where you have a separate ring for the friction material on the disc and the center material. So this costs a lot less than an entire brake rotor to replace. A little bit harder to get, has to be specific to the car. This is for a 1980s BMW, and comes with these nice calipers to help it stop better and dissipate heat a little better than it could from the factory.
Great, thank you. So we'll go back to the presentation then. So that's kind of the two fundamental brake systems that even today are on all cars. Fundamentally, they haven't changed that much over the decades. There's been a lot more fine tuning to them, but they've evolved. So back in the day, most of your antique and vintage cars, like the MG behind me, it had drums front and rear. Drum brakes have problems though. The heat isn't dissipated nearly as well, although Alpha really worked to overcome those with the cooling fins I showed you on the drums there. And therefore, they're more prone to what's called brake fade. Brake fade is when your friction material gets so hot that it releases gases, and then what happens then is those gases ruin your coefficient of friction, and your car doesn't brake as well. Okay, so then the other problem with drum brakes is the technology working?
Hold on.
Okay, we'll take a quick break here to get the technology caught up here. Not sure what's happening with the technology.
Just one moment here.
Okay, so like I said, I'm very thankful to have my tech guy here fixing all this because I couldn't be doing it. We got a momentary glitch here.
Yeah.
Bear with us while we get caught up with the technology. So.
Sure, looks like it.
Are we online?
Looks like it. Give me 1 minute. Come on.
Okay.
There we go.
We're online. All right, great. Sorry about that, folks. We had a technical glitch there. It looks like we're back online again. So, so are we in presentation mode?
I'll go back.
Okay, we're going to get back in presentation mode. And okay, we got somebody else joining us, and we're sharing. Okay, so I just repeat myself because I wasn't quite sure where we got cut off there. Antique cars like the ones behind me have drums at all four corners. They don't dissipate heat very well. They're more prone to brake fade. Are we having problems?
No, we're good.
No, we're good.
Okay, good. Also, if you drive through standing water, water can get inside the drum brakes, cause problems. And so disc brakes really came around in the 50s. Jaguar had a tremendous run at the 24 Hours of Le Mans using disc brakes, and then it really started taking off. Today, you still find drum brakes, though, on the rear end of economy cars, as they are still, believe it or not, cheaper to manufacture than disc brakes. And virtually all medium to high-end cars have disc brakes today at all four corners. So this is, again, showing a basic circuit then. So, again, we've got the master cylinder right here. Here we've got the front disc brakes. And then over here we got rear drum brakes on a car with drums in the rear. And we have a little circuit that kind of splits up the hydraulic fluid to go to the four corners. And we also have something here called a proportioning valve, which reduces the amount of pressure going to the rear brakes. The rear brakes don't work nearly as hard as the front brakes. The front brakes do most of the work. The rear brakes, you don't want as much force going to the back, so you have a proportioning valve there. So this is the classic discs in front and drums in rear. In this older design right here, the two front brakes were connected together hydraulically. They worked in tandem. And the two rear brakes were connected together. They worked in tandem. But then Saab and some other companies started doing some work where they said, you know what, let's do a diagonal split. So in the diagonal split, actually the opposite corners of the car are tied together. That's called a diagonal split. That way, if you lose one brake circuit, you've lost a brake hose or something, you still have brakes at two corners of the car, and they're at opposite ends of the car. With the older design, if you lost a circuit, you might lose all your brakes in the front, and that's more problematic. So that's the more modern design there. The brake systems are biased, so the front brakes do about 70% of the braking. The rear brakes, I kind of say that they're going along for the ride for the most part. So let's move on to the next topic. So let's talk about some common brake caliper designs. So there's basically a fixed caliper, and we'll show you some calipers in a minute here. And they can have two or more pistons. A Porsche Cayenne has 10 pistons in its design. And then you have a sliding caliper, very common on most BMWs. These are single piston in design. They're more economical to produce. But as your brake pads get larger and larger, they become problematic in terms of how they perform there. So if you want to switch to the camera now, okay, so this is an old BMW E46 caliper. So it has your hydraulic cylinder right here. It pushes against the piston, it pushes against the pad. And on the outer side, there's no piston. It's just like fingers right here. So you got fingers, and you got a piston here pushing against those fingers. And that's really common, widely used in lots of cars. This next caliper I have here is off of a Mercedes SL Roadster. This is a fixed caliper design. It's bolted to the axle. It doesn't slide around like a floating caliper or sliding caliper, which kind of slides around on pins. This is fixed. And in this case, it's got four pistons. It's got two on the inside, two on the outside. So now I have fingers on both sides. Imagine two fingers here and two fingers here pushing against each other. And so it spreads the force out, and it gives you more even braking force there. So those are the two fundamental caliper designs. And if you move on to the next slide, back to the slide deck. So then let's talk now about power-assisted brakes. So cars behind me, neither of them have power-assisted brakes, but as cars became heavier and heavier, they really needed something to help the driver out in terms of amplifying the force from the brake pedal there. So the picture on the right is from a mid-'80s Mercedes diesel wagon, but these all look pretty much the same. You've got that black can in the back. So you got this black can right here. This can has a membrane in it, and it has vacuum, and it's kind of like a vacuum amplifier that helps you get more force on the pedal. Over here, underneath all this stuff is the master cylinder itself. And then over here, this is your brake reservoir, where you've got the brake fluid in for the system. In this case, these little black buttons here, those are actually sensors that tell you if the fluid level has dropped too low there. So if we can go to camera for a second, I've got right here a master cylinder setup. This is from the 61 Giulietta here. So back in those days, a lot of sports cars had the pedals mounted from the floor. The old Volkswagen Beetles, this MG, this Alfa Romeo, they were floor mounted. So this kind of sat in the floor, and then you as a driver, this was your brake, this was your clutch right here. And then underneath the floor, underneath the car, here's your master cylinder here. Nowadays, nobody does this anymore. They're flipped over the other way. And so now the pedals are hanging, and I had some brake fluid dribble out there. And, and so now the master cylinder is under the hood of the car and not underneath the car like it is on these old cars here. So going back to the slide deck here, let me move on here. So that's kind of the fundamentals about how brakes work in general. Now we're going to go on to parking brakes. Outside of some quirky vintage Saabs, the parking brakes are at the rear of the car. And for almost 100 years, they were cable operated, and they could either be activated by a handbrake between the seats or by a parking brake pedal to your left-hand side. So if you have a car with rear drum brakes, you have a cable that goes to those drum brakes, and it actuates the shoes, pushing them against the drums. So it's independent of the hydraulic system. If your hydraulics fail, this cable system still works. Having said that, I'm kind of leery about calling it an emergency brake. It's really meant to help you stop on a hill or keep your car from rolling. But in an emergency, if you were to lose all hydraulics, it's better than nothing. Put them on very gently and slowly put more and more force on them, and they will help you stop the car. But you won't have nearly the stopping distance you have with a good hydraulic brake setup. For numerous cars, numerous Alphas, BMWs, and Benzes, they actually have two brake systems in the rear. They have the hydraulic system, which stops the car normally. And then inside of that, they have a little shoe brake system. So, Alex, maybe you want to show, if we want to go to the camera, on the inside of your rotor. So this is the inside of a 318 rotor. And so you can actually see, this is like a brake drum right here. So you have a little bitty shoe brake mechanism inside of here, which you activate with your parking brake cable, expanding those little shoes out. And I think over here I actually have them. So here's some shoes. I believe these are off of, these might be off your Honda. But anyway, these fit inside of here. Yeah, this is off of a Honda. So they wouldn't do much on a conventional braking system. They're pretty small, but they're only meant to hold the car as you're parked right there. So these sit inside of that. So you basically have two separate brake systems, the parking brake and the conventional brake. The other thing is, I'm sorry, go back to camera one more time. This is a caliper that's on the rear of a Saab, but I've seen this on tons of other cars too. It actually has the parking brake integral to the caliper. It's not a separate system. So the manufacturer doesn't have all the cost of those extra shoes and springs and everything else. So on this one here, it's got a little lever. The cable goes here. It squeezes this. And when it squeezes that, it pushes the piston out mechanically. There's a little mechanical setup inside of there. So that's how, you can go back to the presentation now. So that's how that style works. Starting in 2010, I'm just waiting to see if the technology catches up with me. Starting in 2010, you started seeing more and more cars with an electrically activated parking brake. And so basically you have a toggle switch that's in your center console, and you pull on that toggle switch. It's like a little electrical switch. And basically there's a wire that goes back there, and you have little electric solenoids that activate the parking brake. So are we okay technically? Okay, just checking. So that's how that's become more and more common in the last decade, and I imagine it's going to become pretty ubiquitous after a while.
Yep.
Because you get rid of the parking brake cables, and with parking brake cables, they eventually stretch, they break, they rust. So you get rid of that.
Hold on.
Okay, so.
Hold on. There we go. I got a slide update.
Okay, so we're now going to talk about some key inspections and warning signs of impending failure. Are we okay, Ethan? Muted?
There we go.
Okay, so we're hopefully back online again, and we're now going to talk about inspecting your brakes. And so whether you do it yourself or whether you have a mechanic do it, in many states like Pennsylvania, we have mandatory annual inspections, and they look at them every single time. You should look at them at least once a year, every 10,000 miles. Basically, there's a number of things you want to look for. You want to look at the general condition of the discs. Are there any big grooves cut into them, damage from road assault, heavy corrosion, anything like that? You want to look at the brake pad thickness. So as your brake pads wear, think about as a bicycle growing up, as a kid when you had bicycles, those brake pads get thinner and thinner because the friction just wears everything away. You want to make sure your parking brake performs fine. You want to look at your flex hoses. So at the corners you got pipes going to the corners of the car, and then at each corner of the car, you have rubber hoses that go to your wheel cylinders or your calipers there. You want to make sure there's no cracks in those hoses, and any cracks, you'll fail in Pennsylvania on that. But you should also consider replacing them every 15 years, because what happens with brake hoses is they start to fail on the inside. You may not see them from the outside, but on the inside, they're beginning to collapse. The metal lines, you want to look at the metal lines and make sure you don't have any severe corrosion or any signs of fluid leakage. The brake fluid, we'll talk about this in a moment. You should be replacing that every 2 to 3 years. And then you should have the brakes looked at immediately under the following conditions. So number one, if your brake pedal is traveling much further to the floor than it normally does, you've probably got a leak in the system somewhere. Two, you should every month look under your hood, check out your fluids. If your fluid level is dropping in that fluid reservoir, very visibly, that's wrong. You're leaking somewhere, so you should really take care of that. If you hear a grinding noise upon braking, that could mean your pads are at the end of their life, or it could mean that the pads are seriously damaged by road debris or something. If you hear a metallic screeching, if you have severe vibration upon heavy braking, they call that judder. If you have a warning light that comes on the dash, pay attention. Or if when you're braking and you brake hard and the steering wheel jerks in your hands, it's pulling to the left, pulling to the right, you've got a problem. That means you're not getting equal pressure on those front calipers there. So here's one standard light that you may see. It means something somewhere has failed. It means you may have low fluid. It means you may have a pad that is at the end of its life. It could have multiple meanings there. This is common on some of the older cars from the 80s. Basically, this is telling you I've got a pad that's worn too thin and it's time to replace it.
One quick thing. Robert had a question of, with an electric parking brake, presumably it would apply full force if you tried to use it when the hydraulic system failed in emergency. Yes. Basically what you would do is hold the switch into the actuation position, and it'll hold the electric parking brake on to allow the car to slow all the way down like you would with a normal parking brake holding it up. that would still work with a hydraulic system failure in modern electric parking brake cars.
Now, do those come on instantaneously, or do they gradually come on, or how does that work?
They come on gradually, but it definitely makes an alarming noise having done it. But it'll probably beep at you, but they won't release if you don't release the button. So if you just hold that button up or push it in and keep it in, it'll stop you.
Okay, great. Okay, thank you. So moving back to the presentation. So basically, when you have new pads, the friction material itself, you have a steel backing and you have friction material. It'll be about 10 millimeters brand new, going down to 7, 6, 5, 4, 3. Once it gets to like 3 or less, it's time to replace them. So yeah, you can get feeler gauges to do this, but after a while, you can just judge by your eye that, hey, it's about time to replace these pads. And what's nice about some of the modern cars with the open spoke designs is when you're checking your tire pressure, you can just peek in there and see what those pads look like. And they're pretty blatant when you have the big open wheel designs there. Okay, so what choices do I have? I've gotten to the point where I need to replace parts on my brake system. What choices do I have? Well, the quick and easy one is go to the dealer and get a factory part. And many car manufacturers call them genuine BMW, genuine Mercedes-Benz, genuine Alfa Romeo. So, and there's online dealers who will sell them to you wholesale, and it's still the same part as what you would get at your local dealer. One of the things I like about with a dealership is you get free shipping, and you can sometimes get parts there the next day. And I've been to BMW dealerships where I can sometimes get parts from Germany in 2 or 3 days, which is pretty amazing. So that's an intriguing possibility. And don't assume that the dealer parts are sometimes they are super expensive, but sometimes you'd be surprised at their prices. They can be very competitive at times. So that's your choice number one, go to the dealership. And I just got a picture here of a Mercedes box of pads. Now, the next step is called OE, original equipment. This means whoever made those parts that are sitting in those dealers' boxes, they're selling them themselves. Now, they don't have the logo on there like Mercedes stamps on a Mercedes star on them. They don't have that logo on it, but they're the exact same part. There is no difference. And so I got a picture here of Techstar. They're a huge European manufacturer. They sell to BMW, Mercedes, Audi. I don't know if they do Alfa or not, but they're pretty ubiquitous in the European market there. And you go buy Techstars and they're every bit the same as what you would get at a dealer, maybe 10 or 20% cheaper, depending. The next step is OEM. That means it's a company who makes parts for a car company, but they don't make this particular part for your car. So for example, back in the 80s and 90s, Bosch was a huge supplier to the Germans and Alfa Romeo, and they made fuel injection systems. But if you go to your car parts store, you can buy Bosch pads, you can buy Bosch filters, but they didn't sell it to those car manufacturers on the assembly lines. But Bosch is a very reputable brand, and they have quality control and automotive engineers. So in general, they should be of quite decent quality what you get from the OEM, and it should be even a little less expensive than an OE or a factory part. The final category is the aftermarket. So this is wild, wild west. It can range all over the place. I've seen, particularly when you're talking about performance parts for your car, like suspension parts or aftermarket brake parts. We'll go to camera in a second. They can be of phenomenal quality, or they can be absolute junk. And so buyer beware. There's all kinds of quality out there. But on some of these older cars, you have no choice but to get aftermarket parts. There just is no genuine parts anymore, and there is no more OE parts. So you got to take what you get, unfortunately. And then, on the left-hand side, I kind of show the price scale going from most expensive down to least expensive. But the final thing I want to make a point of is buyer beware. Counterparts have become a huge problem. There's companies in third world countries who will make a knockoff part that looks like an OEM part, but it's not. And some of them are just absolute junk. And they'll put them in a box like this yellow Techstar box, so you'll think you're buying the real deal when they're actually counterfeit parts. And so that's why you got to be careful on eBay. I think eBay is phenomenal for getting used parts and whatnot. But when you're buying new parts off of eBay, be cautious there. You don't know, they might be selling you counterfeit parts, whereas a dealer has so many controls in place, they would hopefully never sell you counterfeit parts because the car companies have tight control over that. Okay, so let's talk about brake fluid now. So with one exception, silicone fluid, all brake fluids are what are known as hygroscopic. They suck moisture out of the atmosphere and they just get wetter and wetter and wetter. There's no way around it. And contrary to what you might think, it gets into a brake system, even though it looks like it's a sealed system. You're looking and say, well, I've got a cap on it, and how in the world is moisture getting into it? It can get in through the hoses. You go through water, it can get on the hoses and get in through the hoses there. As the moisture content in the fluid rises, the boiling point of the fluid drops. And then also, besides dropping your boiling point, which we'll talk about in a moment, it also can start corroding the inside of your brake system and start doing damage to your master cylinder and other parts there. And so then the fundamental problem is, we talked earlier about driving on the highway and slamming on your brakes, and those brakes spiking up to 200 plus degrees Fahrenheit. All your brake components are now getting super hot. Those brake components have brake fluid inside of them that are pushing against your pistons. That fluid gets hotter and hotter and hotter, especially if you're doing like a track day, and then that fluid starts to boil. And when that fluid starts to boil, you start getting vapor pockets inside of there. And those vapor pockets, all of a sudden your brake pedal feels soft and spongy. It's because you've got boiling fluid inside of there. So that's a problem, and that's why you don't want to get fluid that becomes super moist there. So I just have a picture here of fresh brake fluid versus aged brake fluid. It starts picking up debris, water, other things. It's not the same as fresh fluid. So if you just go to camera for a second, so you can go to any car parts store or Walmart, and this is a Prestone Dot 3. So that's your basic commodity brake fluid. You got a Dot 4 right here. Your Dot 4 has a higher boiling point than a Dot 3. And usually the Europeans spec out Dot 4 in their systems. Why is that? Because think about the German Autobahn. You've got people driving on their highways in Europe at some pretty high speeds. Dot 4 is more resistant to boiling than Dot 3. Mercedes has their own fluid called Dot 4 Plus, so that's another category there. And then last but not least, it's hidden behind here. You've got here a Dot 4 racing fluid. Notice it says here 579 degrees Fahrenheit. So that's the boiling point on that. So if you go back to the presentation now, this slide here just kind of shows you the different dot levels. And in the, is it showing up? Okay, in the left-hand column, it's showing you the boiling point. So you can see Dot 3 boils at 401, Dot 4 at 446, Dot 5.1 at 500. So you got higher and higher boiling points. No, they also have a term called wet boiling point. This is what happens when you have roughly 4% water in there. Notice that you drop your boiling point by over 100 degrees once you get water in there. So clearly a problem if you're dealing with huge amounts of heat. I'm going to say a few words about silicone fluid, because silicone fluid back in the 80s and 90s used to be all the rage in the enthusiast community. The promise of silicone was that it didn't absorb moisture. You didn't have to replace your fluid periodically. That was the promising point of it. The problem with silicone is it's not compatible with regular fluid. So if you switch over to silicone, you need to flush all the old stuff out of your system with methanol, replace all your seals, put in the silicone, and then never put in conventional fluid again. So it is incompatible with regular fluid. So just something to think about there.
In addition, ABS systems do not function with that Dot 5 silicone fluid because of the viscosity difference.
The viscosity is all wrong. So I would be leery of Dot 5 unless I was like a Jay Leno and I had a huge garage of cars that I didn't want to be changing fluid on all the time. So here's your options for replacing your fluid. Here in Western Pennsylvania, it's going to cost you about $100, $150 to flush the system. They have a special machine that pushes all the fluid out. They cycle the ABS valves on the modern cars, get out every last ounce of those old fluid in there. You can go to an independent mechanic. They'll charge you less. They may or may not have the full capabilities of a dealership, but they should be able to do it. You can do it yourself. Alex and I do it all the time, but proceed with cautions. There's some things that can go wrong here. One, you can accidentally get all the fluid out of your system. Now you got air everywhere, and then you're in a world of hurt getting all that air out of there. Two, you can break your bleeder valves if they're corroded, and then you still got to start replacing calipers. So proceed with caution there, but certainly an experienced do-it-yourselfer can flush their own fluid. We are never going to get every last ounce out like the dealers might be able to, but you're going to get out 97, 98%. So it should be fine. So let's move on to talking about safe practices when working on brakes. So first of all, I'm wearing gloves. Alex has gloves over here. This is filthy work. The brakes are covered with brake dust, which is not good on your skin. It's covered with rust. You've got brake fluid, which attacks your skin. You don't want to get it in your eyes. You don't want to get it on your paint. If you get brake fluid on your paint, it'll eat your paint like paint remover. So that's a word of caution on brake fluid there. And you're also maybe dealing with this stuff right here. You may be dealing with brake cleaner. You can get this at Walmart, any place else. This stuff's pretty powerful stuff. It also can burn your skin, burn your eyes if you get it in the wrong place there. So moving back to the presentation. So one other thing is when you are working on your brakes, are we up to speed on the technology? Okay. Be very careful. You got to get your wheels off the ground. I like to do one corner at a time if I can get away with it if I'm doing it on a driveway. And you're taking the wheel off. So if the car falls and you got an arm or a leg or your body under there, you will get killed. And every year people die working on cars on jack stands. So be very cautious on what you're doing. On the left-hand side here, I've got a screenshot. These are some Harbor Freight jack stands that had to be recalled because they would fail on people. And even worse, the replacement jack stands from Harbor Freight were failing on people. So Harbor Freight's had several recalls. Don't cut corners when it comes to brake stands. Get high quality jack stands for your car there. On the right hand side, I just kind of Google searched. If you Google search here and you look up crushed by carjack, you get 684,000 hits there. It happens, unfortunately, way too often. I also cringe when I drive by somebody's house in Pennsylvania and they got a slanted driveway and their car's on a slanted driveway sitting on jack stands. And I'm like, all it takes is for somebody to bump it, that whole thing falls onto the driveway, potentially injuring or killing somebody. So just a few words about safe practices there. So let's talk now about the basic steps.
Yep. I had a question.
Sure.
I don't see it right now, but someone asked about Pentacin fluid compatibility with BMWs. BMW and other manufacturers usually recommend a particular type of fluid because they tested it with their ABS system and everything. And it's a good idea to try to stick to fluids like that or similar to that are approved. I can say I think my M3 requests Pentacin fluid. I've used this fluid because it has a much higher boiling temperature, and I know it isn't going to boil on me. The DOT4 standard for that Pentacin is 420 or 430 degrees. This goes up to 580 degrees on track and everything. I prefer that a little bit. Haven't had issues with ABS. Your mileage may vary, but as long as it's a known fluid that's known to work with ABS systems, and it'll typically say on the back of the container, meets federal motor vehicle standards, meets DOT standards, meets this particular manufacturer standards. You just want to check to make sure and research a little bit to make sure it's compatible. But most fluids should be, so long as they're not the DOT5 silicone fluid we were talking about.
So Pentacin is a very reputable manufacturer. They're widely used in Europe for not only for brake fluid, but for coolants and other things. Yeah, they're very reputable. The other thing is except for the silicone fluid, all these different dots are compatible with each other. So you can put some .3 into a .4 system. Now you're going to drop your boiling point. You can put .4 in a .3 system. So they're interchangeable. It's mandatory that they be compatible with each other. There's a lot of regulation that goes into brake fluids because it's such a fundamental safety item. So these manufacturers have to meet a lot of requirements there, and they certainly don't want the liability of selling subpar brake fluid. So I would think for the most part, you should be fine unless you've got some really unusual system. And you know, I kind of chuckled a little bit about the genuine Mercedes fluid. When I read up on this, what it is this has good viscosity characteristics all the way down to -40. So better than the conventional fluids. And so if you think about a world manufacturer like a Benz or a BMW or even Alfa, you're selling in all markets of the world. You're selling cars that go in the desert. You're selling cars that go in the Arctic Circle. So you're dealing with an extreme and ambient conditions, and the car manufacturers want to make sure they have their bases covered with all these different conditions there. Having said that, chances are most of us in the United States will never drive in -40-degree weather. So having a brake fluid that's rated down to -40 may or may not be important to you. But that it is important to them because they're selling in all these different markets there.
You may be miserable in a -40-degree car, but your brakes will work. So that's the important thing.
That's right. And actually all it does is it affects the ABS performance at those -40 levels. The ABS will work better in those really frigid conditions there. So thank you. And moving on to the next section of the presentation. So, you know, research ahead of time what you're going to need so you can have all the right parts and supplies and tools on hand. You don't need to be running down to the Napa store over and over again to get stuff. Think ahead about what you're going to need. Make a little checklist there. Are we presenting okay? Yep. Yeah. So here's some different things that you can do to get information. So YouTube videos. Oh, it's amazing what you can find out there. You can type in brake job on 2005 Honda CR-V, and you might find 20 videos that some home mechanic videotaped on the driveway. The quality can be all over the place. I've seen some good ones and I've seen some bad ones, but at least you get some idea of what's involved in the job that you're trying to do. And if you're a beginner mechanic, you can ask yourself the question, am I going to get in over my head by doing this? So YouTube videos are certainly very useful there. There's all kinds of online forums. Alfa Romeo's got forums, BMW's got forums, Mercedes has got forums. Be careful though, because I've read some of those and sometimes people say stuff that is absolutely false. So that's the problem with forums is unless you know the people on there, you don't know who is truly an expert and who's not an expert. So be careful about that. There's certainly shop manuals as an option. There's factory manuals. We'll talk about that in a second. There's aftermarket manuals. If you're in the Mercedes-Benz world, actually the Mercedes-Benz factory site has PDF files for the older cars. That's pretty cool. You download them for free off of the older cars. Bentley and Haynes are the two major book distributors for European cars. They have a wide variety of books available for the different years of European cars. Ethan's got one for his Saab 900. We've got various BMW books. Having said that, I went to the Bentley website this morning and they stopped with BMW around 14 or 15. I think the cars have become so incredibly complicated that I think companies like Bentley are having a hard time keeping up with it. There's just so much technical knowledge there that it's just becoming harder and harder for Bentley to do stuff like that. But certainly for the older cars, they are out there. There's online subscription services like alldataDIY.com. You can get a subscription fee, like $5 a year or something like that. And you can download PDF files, print them out of what you're doing. That's pretty cool. Although BMW refuses to license their information, so you can't find BMW information on this service. Every other car company they've got. If you have a newer car with that electric parking brake, proceed with caution. There's a special procedure you need to follow when you're replacing those pads. You need to deactivate that parking brake, releasing pressure on those pads back there before you do the pad job. So look it up, read it up. And so you can probably Google search it and say electric parking brake 2019, BMW, yada, yada, and you'll find a procedure for it. But make sure you follow it, because you don't want to skip that step right there. So if we can go to camera here for a second. So what I wanted to share with you here is just kind of shop manuals over the ages. So here is a shop manual for this Alfa Romeo here from the 1950s. Notice that this is the entire car in maybe 3/4 of an inch of paper there. And then moving along to the 80s, this is Haynes. Haynes is a British company. They did a lot of stuff. Basically, Haynes would buy cars, they would do the work, and they would take lots of pictures. Some of the pictures aren't the greatest quality, but it is something. So Haynes is pretty popular for the European cars. This is getting a little bit thicker here. Then if we move along here, we come up now to the 80s. I have here a Mercedes factory manual, and this is volume 1. I don't even know how many volumes they have, but notice it's getting even thicker because cars are getting more and more complicated. And then if we move into the late 80s, here we have a Bentley manual for a 3 Series from the 80s. That's called the E30, getting even thicker. If we move along to the 90s, we're getting even thicker. So this is the E36 series right here. And then I started noticing in the 2000s, the factories started putting everything electronically. They just got so big. There is so much information and so much complexity on modern cars that you really can't do it justice in a paper book anymore. So it's pretty much all electronic now. Okay. Moving right along, if we go back to the presentation. So some words of advice here. So are we presenting? Okay. So work on your car one side at a time, meaning do the left first and then do the right, vice versa, whatever. Because if you take one side apart and you're not sure how to put it together, you can go to the other side of the car and take a look and see what it is on the other side of the car, because they're mirror images of each other. So take lots of cell phone pics. That's the beauty of the modern world, is you can take a lot of pictures very easily and have on your phone lots of pictures. Because believe me, I can't tell you how many times we've done a project where we thought we'd be done in a couple of hours, and it ends up being 2 days, 2 weeks, 2 months. And then you start forgetting what happened when you took it apart, because it's been so long since you took it apart. So take lots of pics and do one side at a time. One other thing, brake fluid is hazardous waste. It eats your skin, it eats paint. Dispose of it properly. If you do oil changes, you can just mix it in with your oil and get rid of it that way. So let's go talking through an E46 wagon. Pretty standard setup on the E46 wagon, but this is his girlfriend's car's Hannah that we've just finished up now. We had a major issue getting those brakes fixed. We'll go over that why in a minute. So the problem that she had was her brake pedal was going all the way to the floor before the brakes would come on, and the parking brake simply wouldn't work. So we determined that the brake travel was coming from the fact that there was a bad leak in one of the lines due to heavy corrosion. And we also decided we needed to take apart that rear brake, because remember, the parking brake is inside of the disc brake. So you have to take apart the regular brake to see the parking brake. So here on the left-hand side, you can see in that picture, it's pretty gruesome there. You can see all the corrosion in that picture there. Now, understand, we live in Pennsylvania. Anybody who lives in the north is used to dealing with winter road conditions and salt being put on the roads, and salt is everywhere. And so salt just attacks steel. And so I'm always jealous of seeing people's cars in the South or out in California, because they're clean as a whistle. They don't have the corrosion to fight that we do up north. So this is what we were dealing with on her car with this heavily corroded line here. So I'm going to tell you the rest of the story. We probably spent weeks trying to figure out what to do with that without damaging the car. You took a wrench to it, nothing would happen. It would just round the nut. Ethan here ended up with a cutting wheel, just very carefully cutting everything away, and then he ended up fabricating in a whole new brake line. We have a kit for making flare fittings. We've got brake line. You can cut it to size. You use a tubing bender, and you can. So that's a pretty advanced process if you're not more familiar mechanic, but you can fabricate your own brake lines. There's kits out there to do it, but I wouldn't recommend it for a beginner. But the reason we did that is if according to the factory, the correct way of doing it on this car was to drop the gas tank and drop the axle, because the brake lines were underneath the gas tank. I'm like, I'm not dropping the gas tank. So we figured out another way to safely work our way around that. So then the next thing you do is you take off on the step number 2 here, there's a clip you take off. You undo some Allen head bolts to loosen up the carrier. Remember, this is a sliding caliper we have on this one. There's some specialty Allen head pins that is on this car. If you're working on Allen head hardware, get sockets. Don't use Allen head keys like I have in the picture here. I only have that in the picture because we didn't have any sockets that fit that. But in general, use sockets, because if you try to use an Allen key, particularly on Alfa Romeo rear brakes, I've been there, done that, and you end up rounding the inside of that bolt, you're in a world of hurt getting that bolt out of there. So be cautious there about doing damage. Some cars use Torx head pins. They're like funny little stars on them. Some use hex head pins. I mean, that's the thing. Every manufacturer has their preferred hardware. And so anybody who works on lots of cars has to have lots of different tools for all these situations. You take off the caliper from the carrier using a pry bar. We got a caliper. What we did is once we took it apart, we measured the pad thicknesses. And what we found is that on one side, the rear pads were half the thickness on one side of the car than the other, which means the brake pressure was not consistent from one side of the car to the other. So the previous owner had just replaced the pads. They had also replaced the caliper, and the caliper was a low-quality rebuild, and therefore it was not retracting all the way, so your brakes were dragging all the time. So it was causing some of the brake pads to wear faster. This is a problem out there. The caliper rebuilds are all over the place. I've bought rebuilt calipers that are pretty excellent, and I've bought some that are pretty terrible, and so it is a problem out there. The safest route is to go to the dealer and get rebuilt calipers. It will cost you several $100s versus going to a car parts store, but that is your safest bet. So anyway, we had to replace the caliper again because the last caliper was a poor rebuild. We checked the thickness of the disc. So all rotors have to have stamped on them the minimum thickness on them. You can't get any thinner than that. It's a legal limit there. It's stamped on the disc. So Alex is yours don't. This one behind me on the floor, I know it has it on there. You can also look it up online, Google search it. They must be replaced if they're at the legal limit. They should be replaced if you're getting close to the legal limit. And if you live up north like we do, oftentimes, every time I've replaced pads, I have to replace the rotors because they've been attacked by corrosion so badly. So that's a problem. Newer cars have gotten better and better on the metallurgy. The metallurgy on new cars is so much better than on older cars that they're much more corrosion resistant, even versus cars 10, 20 years ago, I would say. So you take your caliper off. Don't hang it by the hose. That stresses the brake hose. Use a bungee cord, hang it up. Take off the caliper bracket. And by the way, these slides are available to anybody who wants them. I can send them out to anybody who wants them. You got a retaining screw that mounts the disc to the axle. It's pretty common. Now, if you're not going to reuse the disc a second time, if you live up north, you're just going to have to take a big mallet and beat the crap out of it to get it off because it's probably corroded onto the hub there. This now is we're looking at the parking brake, and we see now why the parking brake doesn't work. So there you can see a crack in that parking shoe there. And over here on the, whoops, wrong thing here. Let me just get out of here. And then over, oops, I didn't want to do that. Let's go back here. On this right-hand side here, you see cracks and gouges. So basically somebody drove with the parking brake on for many, many miles. And it gets hotter and hotter and hotter. And then the material starts to disintegrate and crack and fall apart. So that's why you don't leave your parking brake on for many reasons. You'll destroy the parking brake. Otherwise, parking brakes often last the life of the car because you're not really using them in their friction capacity. You're just using it to hold the car on a hill or on your driveway. They really don't work that hard. If your car had a fixed caliper design, it's really not terribly different. The nice thing about a fixed caliper design, you don't have to take the caliper off. So you have some pins that you've got to drive out. You use a little tapping pin and you drive those pins out. I know Alfa Romeo uses those. You got a spring that you got to pull out with a pair of pliers. You pull the pads out with needle nose pliers. And then here's the tricky part. You've got to have a special tool to push the pistons back in. So Ethan, if you can go to camera here for a second. So I've got here this fixed caliper. It's a 4-piston caliper right here. Now, imagine if I were just trying. So what happens is, as your brake pads wear, they get thinner and thinner and thinner. And then the pistons come out further and further and further into this opening right here. And then when it's time to put in new pads, the pads won't fit because the pistons are so far out. You've got to push those pistons all the way back in to their starting point in order to start with a fresh set of pads. And on a simple single piston design, all I need to do is with this one piston here, use a tool to push that piston back in, and we're done. On this one right here, if I were to try to push the pistons on one side, the other side pistons would start to come out because they're tied together hydraulically. So there's a special tool you can get. You can get these off of Amazon. Basically what it does is it fits in here, and it's like a C-clamp right here, and it basically spreads those pads. It's called a pad spreader. Amazon's got tons of these. So look up pad spreader on Amazon, and as you tighten it up, it pushes those pistons back into the caliper. So that's what a pad spreader looks like. Okay, so if we go back to the slide deck here, so as the old saying goes, are we presenting okay? Okay. As the old saying goes, reassembly is the reverse of disassembly. In this case, you do brakes in pairs. Okay, so you don't do just the left side of a car, you do left and right simultaneously. And when you buy a set of pads, they sell you pads for both sides. You don't buy a box for left and a box for right. They all come in one box. It's usually a good idea to do discs in pairs too. Parking brakes, they come in kits with stuff for both sides. You do both sides. The one thing I don't like about working on drums is they got those funky springs that go in 20 directions sometimes. And so special tools help there with those springs, getting those springs back on. And you want to replace those springs too, because those springs get heat aged, they get corroded. They're not the same as when they were brand new. You want to take like a wire brush to your hub, get the corrosion off of it, put a light coating of anti-seize grease on there. That'll help you the next time around getting that rotor off the car because it won't rust onto the hub there. If you were planning to replace the discs, get new rotors, get new retaining screws. The other thing to say here is, if you can go to camera, Ethan, if you can pick up here, I'll pick this one up here. When I get a new disc out of the box, it may come in 2 different ways. So one way is everything is painted. All these friction surfaces here are painted silver. This is called the hat. The hat is painted silver. Yeah, you've got everything here painted silver. You don't need to take that paint off. First time you apply the brakes will take that paint right off. So you don't need to worry about that. The paint is there so that when the brakes are sitting on the shelf at the car store, they're not corroding due to ambient humidity there. Okay. Now, some rotors come with a thin layer of oil or grease on them. You want to take some brake cleaner and a paper towel and get that grease off there. You don't want to leave that grease on there, but that grease is there to protect it so it doesn't rust while it's sitting on the shelf there. So if you go back to the presentation, okay, and so now, okay, so you got to get those pistons back into the caliper. If you have a rear caliper like that Saab caliper I showed you with the built-in parking brake, look at the procedures online or in a book or whatever. Sometimes those pistons need to be turned clockwise to retract them. You can't squeeze them in. If you try to squeeze them in, you may destroy the caliper in the process. There's a tool you get that twists them inwards, kind of in a because there's there's a threaded rod inside and it rides on a threaded rod. So you need to make sure that you got the right tool if you're dealing with those Saab style calipers there. Some calipers, like those Saab calipers and Alfa Romeo rear calipers, they have adjusting screws. That's another reason to read up ahead of time on what you're getting into. And you got to use feeler gauges, and you got to set the gap there with those adjusting screws. More on that in a minute. Put everything back together. There's special stuff you can get. Any car parts store has it, called caliper grease. It literally says caliper grease. It's rated for high temperatures. Get that stuff. Don't use run-of-the-mill grease. It'll become runny and get all over the place under those high temperature conditions. Caliper grease is able to withstand hundreds of degrees without flying all over the place. You put in your new pads. Oftentimes on the older cars, you put a little light film of that caliper grease on the back of the pads. On the newer cars, there are shims on the cars, so you don't even need to put grease back there. Go sparingly with the grease, though. Don't go overboard, because otherwise it just splatters everywhere. And then when you put it back on, if it's that sliding caliper design, you put grease on the guide so it slides back and forth. You want everything to move smoothly and without friction, so that everything is greased up nicely there. Put the retaining spring back on. Now when you got everything back together, one more pro tip, particularly if you have alloy wheels, put a little bit of this, we call it anti-seize grease or copper grease on the hub there. So that way, the next time you take the wheel off the car, it comes right off. You live up north and you don't put grease there, and you have a flat tire on your side of the road, and that darn wheel doesn't come off the car, it's frozen onto there because of the rust. So grease is very helpful there to keep that from happening again. So next topic. What if I decide to attend a track day? So always start with fresh brake fluid, preferably a 4 or a 5.1. Remember, if you don't have fresh fluid, you've got water in there, it's going to boil, and you might have brake fade out on the track, which you don't want to have going at high speeds where you lose braking effectiveness because your fluid's boiling. You might want to go to a higher performance brake pad. Many street pads do not hold up well in continuous high-speed braking. They just start disintegrating on you. If you are going to use street pads, make sure they're relatively fresh and they're not at the end of their life, because you're going to be putting some hard abuse on those pads. So don't be using pads at the end of their life out on a racetrack. So, we
basically got two pretty popular brake pads. These top ones are more of a street sort of aftermarket pad. They're HPSs. They're a little better for performance driving than your typical factory pad. This is what I have on my older BMW that I might take autocrossing or daily driving, but not really tracking that much. Then these pads are a lot more aggressive. They're DTC 60s. They're about as aggressive as it gets. These are full-on race pads. They're usable on the street. They're still safe in normal temperatures and everything. They dust like nothing else. They squeak and shatter and make all sorts of bad noises, but they will not stop braking. They don't fade. They go up to 1,300 degrees Fahrenheit before their friction starts falling off. They're what you want if you track your car seriously and want to have confidence in hitting the brakes from triple-digit speeds over and over again. So these are just two popular options. Hawk makes great pads. There's various companies that make great pads, but I just go with Hawk with a lot of my pads.
Hawk is carried on TireRack.com, so they're a very reputable brand. The other thing that Alex and I have chatted about is it used to be back in the day that racing pads should only be used on the track, and then when you got off the track and went back home, you needed to swap them out because they were so bad on the road. They didn't have any coefficient of friction at low temperatures, and so your braking distance would be terrible. They've come a long way on the friction material on racing pads.
I daily drive my M3 with these. They're loud with the windows down and everything, and I'm sure the people around me are thinking, why on earth do his brakes sound like that? But with the windows up, they aren't that bad. They stop just fine, even in freezing cold weather. So your mileage may vary, but nowadays race brakes can be daily driven if you can tolerate the sound, which is sometimes a big ask.
So one other thing while we got the camera on here, so just saying a few words about hoses. So this is a run-of-the-mill rubber hose, off of a BMW, brand new, never been used. You can get these for like $10 or $15. Any of the reputable brake manufacturers sell these ATE. You don't have to get them at a dealer. The dealers do usually charge a lot more. This is an aftermarket hose. It's a stainless steel braided hose, and it's got like a polymeric coating on it. So these are kind of racing style hoses. So let's talk a few minutes about that, because I get questions about these kinds of hoses all the time. So as Alex has pointed out to me, even your high-end manufacturers like Porsche uses rubber hoses. The braided hoses come from the racetrack world, where people were concerned about debris on the track hitting and severing a hose and you losing brakes. And having said that, usually on race cars, people are replacing their hoses quite often here. So these aren't, these are perfectly fine. Now, having said that, in the real world, I've heard horror stories of people being out on track days and these things blowing out on them because they were a subpar hose. So maybe you can say a few words about these style hoses.
So just for longevity's sake, all OEMs, whether it be Ferrari, Porsche, BMW, what have you, still use rubber hoses. They're just a little more trustworthy from our durability test point of view and everything. You won't find stainless lines on them. And stainless lines can feel better to your foot and may give you a little better confidence. They won't stop the car any quicker. You're still going to build up brake pressure with a rubber line. So maybe a few inches more, a few millimeters more pedal travel versus the potential of having a brake line failure. There's DOT rated lines, and those are a good improvement over it used to be. There are no DOT rated stainless steel lines, but for a daily driven car, I just run new good rubber lines in them because I don't want to deal with inspecting them super regularly like you would a stainless line. We got a question of why are race pads louder? That's a great question. In almost all of engineering, there's always a trade-off kind of triangle or diamond shape of what do you want? Do you want it to be inexpensive? Do you want it to last long? Do you want it to stop well? Do you want it to make a lot of noise? And race pads are pretty much optimized to stop incredibly well, have incredible heat tolerance at the expense of everything else. So they dust more. They put a lot of black charcoal dust out that doesn't look great on your wheels or anything, and they make more noise because that's not what they're designed for. A lot of the noise is from the amount of metallic material in the brake pads. So you have it chock full of copper and iron. So on track, I've been told, I'm not looking at them, but the people behind me say that they sometimes spit sparks and stuff out. That may be normal depending on what pad you have. But they don't care about the noise. All they care about is stopping car as hard and long as possible, basically. They don't have the compromises your factory pads might have.
Okay, so yeah, good discussion there. So to Alex's point, when you're pressing on the brake pedal and you're creating all those PSI inside of a brake system, these rubber lines will expand ever so slightly, whereas these stainless steel hoses will not expand hardly at all, much less. And that's why your brake pedal feels better. So your brake pedal feels better because you're not having to deal with a line that's slightly expanding. This is much more rigid. Having said that, you're not going to stop any faster. It doesn't help you on performance at all. They do look good, but it doesn't really help you on performance. Okay, so if we go back to the presentation, so ideally, if you do take your car on a track, when all is said and done, you want to flush your fluid. You've really cooked that fluid pretty badly, particularly if you've done a lot of high-speed braking on long straightaways there. You got a track with long straightaways, you built up a lot of heat. Get that fluid out of there and get some fresh fluid on it. Okay, so let's move on to a few advanced topics, and then we can move on to we'll be wrapping up, and we'll be happy to answer any questions here. So first thing I want to talk about is anti-lock braking systems. So the modern, they've been around for quite some time, but truly the modern systems were pioneered by Mercedes-Benz. They did it in their S-Class in 1978, working closely with Bosch. And so if you look at this picture right here, this car right here does not have ABS. And this one here, which has ABS written on the hood, has ABS. Notice that what they were trying to do on this wet course here was to hit the brakes and steer around a stack of boxes there on the track. So you have this stack of boxes here. Notice from the tire tracks on the wet pavement that the Mercedes on the right with the ABS was able to not only brake, but keep control of the steering and make their way around the boxes. So obviously you're in a much safer situation in that setup. Whereas on the left-hand side, the dark Mercedes does not have ABS. Notice its tire tracks straight ahead. He wanted to avoid the boxes. He hit those brakes. The brakes locked up. Once your brakes locked up, you can't steer the car. So a lot of people assume that ABS there is to shorten braking distances, and it can. The fundamental reason it's there is for steering. You retain the steering on the car with ABS because you're not locking up those front wheels there. So that's kind of a picture from the proving grounds in Germany back in the 70s. So here's a basic fundamental picture here of the system. So each of the four corners of the car has these little triangles, which are sensors. They measure the speed of the wheel, or the RPMs, at that corner of the car. You then have this ABS module here, and it's tied in with this brake control unit. So if you, I seem to have lost control here. Let's try it again. Let me go back. So if you go here, you have this brake control unit, which is like a computer, which is taking signals from the four corners. And what it's doing is it's comparing the wheel speeds at the four corners. And if it senses that one corner is locking up, that wheel is decelerating very, very fast compared to the others. What it does is say, we don't want so much braking pressure in that corner. So it can modulate the pressure at the four corners of the car. So this brake control unit, this computer unit, it controls this ABS module, and that ABS module regulates the pressure on the four corners. And so it could say, okay, left rear wheel is locking up, let's apply less braking pressure back there. And that way it'll keep the car from locking up and skidding, because basically a skid is when your wheels are locked up. So that's what it's doing there. If you got an Alfa Romeo from the 80s, like the Milanas, and I think maybe the GTV6s, those were in the early days of ABS systems. They actually have a 3-channel system, two sensors in the front and one in the rear. So at any rate, that's kind of what happens fundamentally. And so if you have an ABS light come on your dash, that means your ABS light your system is not functional. In general, they're highly reliable. They don't require any maintenance. If the light comes on, the car is still safe to drive. You just don't have ABS anymore. If you go through wet water, it's not going to work, that it's modulating the pressure and keeping you from getting into a skid. So more often than not, the failure is a non-operating wheel speed sensor. However, you usually need a scanner to tell you which sensor is bad, and then you replace the sensor on that corner. And replacing sensors is, most do-it-yourselfers can certainly do that if you got a scanner. Beyond that, you might need to get some professional help. So did we have a question there on ABS? I saw that out of the corner of my eye.
We have some discussion about ABS, and I have some testing-based data in the contrary, but basically, modern ABS is at the point that, especially in your trickier conditions where you may not have the same traction on all four corners, your foot doesn't have the possibility to change your braking force side to side. As a result, you can stop faster with ABS in inclement conditions. In the dry, threshold braking can stop just as quickly as ABS. Yes.
On that Mercedes track, it was a wet track, so all four corners had the same traction. But that's not always true in the real world.
If you have one side of dry pavement and one side in a slush pile in the middle of the road, ABS can help track you more stably, and stop more quickly than you would otherwise be able to. The difference is usually 30 to 50% on a snow and ice VDA surface, in my experience. ABS has come a long way in the last 30, 40 years of its existence, and nowadays it's gotten pretty darn effective with how quickly it can grab grip out of seemingly nowhere.
Okay, good. And we can talk more about that in the Q&A. So the next topic I wanted to go into, since we have some Alpha people online, and some of you have the 116 series, which is the Alfetta GTV6 Milano series, we're going to talk a little bit about inboard brakes. It's a very interesting system. Actually, it was kind of pioneered by Jaguar. So the Jaguar E-types and many of their SJ series had inboard brakes. But what I have here is a picture from an Alfa Romeo 116 series. And what I wanted to do was highlight the fact that on most cars that we've talked about so far, in fact, 99.9% of cars, the brakes are what are known as outboard brakes. The brakes are out by the wheel. They're inside the wheel. And they're inside the wheel. You take the wheel off, and there's the brake looking at you. It's right there at the corner of the car. On the Alphas and the older Jaguars, the 116 series Alphas, they're in what is known as inboard. They're towards the center of the car. So on this picture from a Milano here, you've got a rear transaxle. So you got your 5-speed transmission and your differential there, all in one unit there. And your disc brakes are right there attached to the transaxle. So that's a inboard brake design. So the advantages are, first of all, what they call lower unsprung weight. Your wheel and hub assemblies are not nearly as heavy because you don't have discs and calipers traveling up and down. So your suspension engineers have a lot more freedom to do some pretty cool stuff where they can balance handling and ride because you've got lower unsprung weight there. You can also fit larger rotors because you're not limited by the wheel diameter. You know, you've got a lot more room to do that. The disadvantage, as I'm sure the 116 owners have run into, is serviceability. You have to take off the drive axles to get the calipers and the rotors off, unlike a conventional outboard disc car. So I have a picture here of an Alfa transaxle. You can see the discs and the calipers there bolted up to the transaxle there. It looks really cool and easy to get at because it's out in the open, but underneath the car, it's tucked up in there, and anybody who's worked on these old cars, it's a hassle working on these because they're tucked up there. Usually you have to unbolt the rear of the transaxle, lower a little bit with a jack to get you more access to those calipers. So it's a little bit more of a pain in the neck here, but it's not impossible for sure. Final drawing of this that I wanted to show you here is, so in order to get those rotors off, unlike a conventional car where I take the wheel off and I take the caliper off, there's the rotor. Here I've got to undo that drive axle right there, and then I've got to undo a bunch of bolts that are holding those rotors on. Because it's underneath the car, the other problem with inboard brakes, it gets very hot there. You don't have nearly as much cooling as you do with brakes out at the corners of the car. When the brakes are in the inside of the middle of the car, they get a lot hotter. And then on top of that, you got an exhaust pipe that's going near there too. It gets really hot. So when you're undoing those bolts, they can be a real pain in the neck to get off of there. I would really suggest a good set of impact hex head sockets and an impact wrench to get them off. Doing it by hand, which I've done, can be a royal pain in the neck. So just a warning there on inboard brakes. So moving on, if you have the inboard Alpha, there's a special technique we can talk about offline on adjusting those pads. There's a special tool you need. You need feeler gauges, and there's adjusting screws to adjust the pads there. So now here's a topic that's ubiquitous for us Northerners dealing with high mileage, rusty vehicles. Number one is patience. When threaded, are we presenting you or presenting? When threaded fittings or fasteners are heavily corroded, the corrosion behaves much like a weld. It's almost like you welded two pieces of metal together, and they can be very hard to undo and very hard to loosen there. Particularly if you have a steel bolt threaded into aluminum, you get a phenomenon there called galvanic corrosion. They can really get quote unquote welded in place there with you have galvanic corrosion. If you just take a wrench to it and you just put in a huge amount of force on it, all kinds of bad things can happen. So number one, snap the head off the bolt, particularly on a smaller diameter bolt. Been there, done that. Another thing you can do is, if it's a hexagonal bolt, you can round the corners on the hexagon, and now you have nothing for the wrench to grip onto. So that's another possibility. And you could injure yourself. If you're pushing with a huge amount of force and that wrench gives way, you may slam your fist into an immovable object. So that's some things that can happen there. And that picture I show you right here is oops, over there, just shows a rounded bolt. It's a pain in the neck to deal with once you've rounded that hexagon there. So what is the solution? Try to plan it so the night before you soak everything with a high quality penetrating fluid, not WD-40. WD-40 is not a penetrating fluid, so don't use it for that. It really doesn't do much at all. If you can put the camera on, Ethan, this stuff is really good. It's called Kano Aerocoil. I got this off of Amazon. B-Buster is another popular brand you can get any car part store. This is actually better than B-Buster. The very best solution is actually a homemade brew of transmission fluid and acetone, but this Aerocoil is pretty good and it can get into some tight places there. So soak everything the night before. You won't regret it because the next day things will come out a lot easier. If that fails, you may have to apply intense heat to the bolt. And there's several ways of doing that. One, you can use an oxyacetylene torch. Are we presenting? Yep. You can use an oxyacetylene torch. We've got one over here in the corner of the garage. Basically, you take a torch to the bolt and you hit it until it's glowing bright orange, red. It's like glowing. And then when you take a wrench, it's like night and day. The whole thing will come apart. What's the problem with a torch? Particularly on the rear brakes of a car, you've got a gas tank nearby. What happens if you hit that gas tank with that torch? You know, really bad things can happen. The other cool thing that if you got the camera on that we've been playing around lately, you know, this is a tool called a bolt buster. And what it is, it's an electrical induction tool. So it's got this coil at the end. Now notice this is pretty big, so it can't fit in a tight space, but if you're doing exhaust work, it really works. And what you do is you take this coil and you place it over the head of the bolt or the nut that you're trying to loosen, and you turn this on, and it generates huge amounts of heat here inductively, electrical induction, without a flame. So this is pretty cool because you're not dealing with open flames and all the hazards associated with an open flame. The disadvantage is pretty big and bulky, so it may not fit where you need it. So that's another option there that's much safer. So carbon brakes. So let me answer
sure. Questions real quick. So we had a question about, does a multi-piston caliper apply more force to a rotor than a sliding caliper? Great question. It can. It's also the limiting factor in most braking systems is what is touching the road, the tire. So if a system can lock up its tires, then it's pretty much performing as best as it can for an ultimate stop. Now, obviously, there's heat and other things to take into account, but a multi-piston caliper is able to apply force throughout the pad a little more evenly. So let me grab.
And when you get to larger and larger brake pads, it becomes really problematic to try to do that with a single piston.
So think if you have a pad that's this long, it's a lot easier to apply force alongside the entire pad if you have multiple pistons at multiple points along your pad to apply that pressure nice and evenly. So that's why there is multiple pistons. A lot of them, 4 and 6, are very popular numbers. The more pistons usually means enormous pads. I've seen pads that are this long with 8 and 10 piston calipers to grab them. And as you go down the caliper, you'll have differing piston sizes that are engineered to basically allow nice and even brake pad wear throughout it. With sliding pistons and single pistons, you're kind of limited on that pad size and can get some uneven pad wear compared to these multi-piston systems. Yep. We had another question. If the brake pads need to be changed, should the rotors be replaced too? It definitely depends. Like he said, the brake discs, I didn't find it. The brake discs themselves, ooh, this is going to be fun, there you go. You can see in this Yeah, it's hard. We have really bright sunlight coming in, but they'll have engraved on them the amount of thickness allowed on them. See if you can get it over there.
So basically, this one says minimum thickness 26.7 millimeters. So take calipers to it and measure, and so the new thickness is probably 27, 28 millimeters. And so that'll what they'll be new out of the box. And particularly with pads that are more abrasive, they'll be wearing away metal too. They're not just wearing away the friction material, they're wearing away metal. And I've seen some cars with pretty aggressive pads that the first time you change the pads, you check those rotors, they look like they're in good shape, but they're already getting close to the legal limit. And they're not going to make it through the life of the next pad before they're below the legal limit. So that's point number one, is check those thicknesses. And nowadays with Google, you can say Google search minimum pad thickness on Alfa Romeo Giulia, and you'll find what the minimum thickness is. You can find it online. But then the other point I had was on the corrosion. I'm looking here at this rotor right here. This is a really nasty one. It's got some serious gouging going on. It's got serious pitting from salt corrosion and more corrosion here and gouges here. And it used to be back in the day that I remember you could run this down to the corner machine shop and the guy could put it on a lathe and they could turn it and take some of this corrosion off and take the gouges out. But nowadays, oftentimes, there's not much metal to work with.
Yep.
So
John mentioned that in the questions. Often costs less, and it does sometimes cost less. Now, there are exceptions, obviously. Some specialty rotors, like these, the special M3 rotors that come on the competition pack, are about 3 times as expensive as normal M3 rotors. So if I still had a little bit of thickness left on them, I'd be inclined to get them turned, because they're close to $300, $400 an axle in rotors alone, and that gets pretty expensive pretty quickly.
but if I look at this old style rotor from the 90s on a BMW 3 Series, these are like $30 each.
Yep.
And then the fronts are like $50 each. So, you know, I usually just toss them and get new ones because they're just not that expensive. So, but certainly at the large, that's the beauty of sometimes of the older cars, is the parts are a lot cheaper.
Yep. We have one more question before we get to carbon brakes. Drew asked, is copper tubing acceptable when making replacement lines? Good question. Copper tubing is definitely easy to make good brake lines because it's so malleable. You can bend it by hand almost and make them. 2 of the cars I have, my CRV and my wagon, are running copper brake lines. As long as it's rated to pressure that the rest of the system is capable of reading, it should be fine. The reason OEMs don't use them, copper is really expensive. And also, when you get your parts delivered on a big pallet in a factory, copper bends really easily and will droop on these big pallets because you have a big pipe from the front to the rear of the car, and steel on that pallet will maintain its shape just fine in the factory, even if someone bumps it or something, whereas copper can be drooped and not install in the car correctly in the first shot, on top of being a very expensive part from a materials point of view alone. With steel lines, you need tools like this, a brake pipe bender, to be able to bend them into shape, whereas copper is a lot easier to do just by hand.
So what you can do also is, you know, certainly on the newer cars, you can buy brake lines from the dealership. Older cars, forget it, but you're going to need a kit to make your own. But you can use your old brake lines as a pattern and just copy the shape on the new lines as you make up the new line there.
Okay.
Okay. So let's talk about carbon brakes. Now, this has become a kind of a popular question now. They're not very common, but I imagine they're going to become more common. First used in 2001, a 911 GT2. They're made of carbon ceramic matrix, so they're chopped carbon fibers inside a ceramics matrix material. Mercedes used them on their SLR McLaren supercar. Today, we did some research. You can find them on M cars, higher spec Alfa Romeos. I believe the Giulia Quadrifoglio has them on there, or available. The AMG has them available. On many of these cars, they may not come on the standard car, even the high end. You may have to order it as an option package.
So to give examples, I know I'm just talking over the presentation. You're good. The the option for an Alpha, Julia, or an M3 is something like $8,000, and on a $60,000 car, that's a really big option. The benefits, if you go to the next.
So the benefits are they do not wear by abrasion like traditional brakes. They only wear at high temperatures. So only if you're on a racetrack do you put significant wear on them. So theoretically, if you're just using it as a driver and you're not taking it out on the track, they could potentially last the life of a car, potentially. They can withstand very high temperatures up to 1800 degrees. They can dissipate heat a lot more quickly. And remember, the name of the game in brakes is getting rid of heat. They're about half the weight of conventional brakes, so they can drop 60, 100 pounds off a car, making the suspension design better, less brake dust, better performance in the wet, last the life of the car. So why not use them? Well, they're darned expensive. So as Alex pointed out, they could be $8,000, $9,000 on a new car. Now imagine you bought somebody's used car, 15, 20 years old, and now you've got to replace them. It may cost you more than the car is worth to replace them.
I had a story of someone bought an older E-Class Mercedes AMG for 20, 25 grand, and the brakes on the car would have cost him $15,000 to do over again. So more than half the price that he had in the car in just a brake job. He converted to traditional iron brakes, which you can sometimes do, which saves a lot of money.
Yep. They're pretty fragile, so some debris might hit it and fracture it, unlike a steel disc. And they can wear pretty quickly on a racetrack. So just a few comments about that. So final topic, kind of more of a philosophical topic. So back when I was in college, this was all the rage. Zen and the Art of Motorcycle Maintenance. Some of you may have heard of it. I crossed out the word motorcycle because everything in there applies to cars too. It was written by a gentleman named Robert Pirsig in '74. It can be a tough read. There's some weird stuff in there, but some really interesting thoughts about working on motorcycles and doing quality work. And I think it's kind of sticks with me to this day. So after many years and mistakes along the way, again, like we're talking about dealing with rusty cars, patience, do-it-yourself car repairs and maintenance can be incredibly rewarding, both emotionally and financially. You can save so much off of a dealer brake job doing it yourself, even if you use dealer parts. I've seen, even on Honda, some dealerships charging over $1,000 for 4 wheels that you can do yourself for about $200. So the savings are not inconsequential. So it can be very rewarding to do it yourself. Having said that, when things start to go wrong, when things start to break, or you snap things off, or whatever, your emotions can start to run high, and you can get into a lot of trouble there. So be mindful, don't rush, be in the moment, don't multitask, think about what you're doing, think carefully about what you're doing, because not only can you damage your car, you can damage yourself. You can injure yourself if you start really screwing things up there. Keep a clean, tidy work area, putting tools away during the job. I've been guilty of this picture here. You're walking past, you kick the tools, and they go flying in 20 directions, and then you spend a half hour finding all your tools. Have a project plan where you think carefully about what you're going to do. Just have a piece of cardboard here on the windshield, Sharpie pen. Keep kind of a methodical list of what you're doing and what you need. Kind of be very in the moment there. And when you're dealing with an older, higher mileage cars, when in doubt, replace it. Don't reuse old rusty hardware that it's at the end of its life. It's not that expensive, but don't go to a Ace Hardware and just buy off-the-shelf, run-of-the-mill hardware. It needs to be automotive grade. So if you go to like a Lowe's or a Home Depot, they do have drawers of automotive grade hardware there that you can buy. So get automotive grade hardware, particularly on brake systems. Working while you're super tired, you had a long day at work, now you're working in the evening, it's 10 o'clock at night, things are going terribly wrong. Don't work while you're under the influence, or when you're emotionally upset, you're in a hurry. If you're in these situations, stop for the day, take a long break. There's always tomorrow. When in doubt, if you're getting in over your head, put everything back together and get it to a mechanic. There's no shame in doing that. This is one of my favorite sayings. Every 20-minute job is one broken bolt away from being a 3-day issue. Been there, done that.
We have two raised hands.
We have two raised hands.
Maxine and the
Okay.
something has to be technical. Maxine.
Maybe she just accidentally raised it. Okay. Okay. So at any rate, in the book Zen, they talk about this being a gumption buster that can just kill you emotionally. Highly experienced mechanics have tools and techniques to bring down that 3-day issue so it's more manageable. And if you do have a good specialist who knows your car, they can avoid a lot of these problems because they know where these problems are and they can avoid them. But another reason to read up online, you can see other enthusiasts who will document this is a known problem area. Be careful here. This is another cute one. For whatever the reason, 10mm wrenches and sockets seem to just disappear on you. They get sucked into a vortex, into a dark cavern in the bottom of your car, and you'll never to be found again. So keep an extra supply of 10mm on hand because they will disappear. They're big enough. A larger size socket will fall and you can see it. A smaller socket like a 10mm goes places where you'll never find it again. So last but not least, just kind of wanted to give you kind of a feel for repair complexity. So I'm just putting everything on a scale of 1 to 10. If you're doing just a tire and fluid check, it's within anybody's capability. Single wrench, oil and filter range, except for maybe a Porsche 911, maybe a 2-wrench job. Replacing pads and discs is a 3-wrench job. Flushing your brake fluid and replacing calipers, you're getting closer to 4 wrenches. Replacing brake lines and hoses, particularly with their rusty, could be 5, 6 wrenches. Master cylinders can be a lot of work. I've been very fortunate over the years. I've never had to do a master cylinder job. Hopefully it's because I've been replacing the fluid regularly, but maybe I've just been lucky. And engine and transmission rebuilds are a 9 or a 10. So that kind of concludes our talk. Hopefully that gave you a better feel for the basic design of a brake system. How do you inspect it? How do you maintain it? How do you repair it? How do you restore it? We've covered a lot of ground there in the last hour and a half. Hopefully you found it useful. But at this time, we're open to questions. So have we answered everything on the question board?
We have one. John had a question that just reminds me of heat transfer class right here. It's kind of interesting. What is the relationship between brake pad area and force per unit area? So that would be PSI there. I'm assuming that the heat energy needed to decelerate is a fixed quantity. It sounds like a heat transfer question, almost heat energy dissipation. So that's a good question. The relationship between brake pad area and force per unit area. Obviously, so you have that PSI on a different amount of area. So the reason why you just making sure I'm nice and centered. The reason why we get bigger brake pads is that so you can lower that pressure per area for the same amount of force going into the system. So your end goal is to have a certain amount of normal force on the back of this pad against this frictional force. That'll give you the amount of force it can stop rotating around, and that'll be your frictional force, mu times F in this instance. With a bigger pad, you need a little less pressure to do it, which means that you can have a higher force along the entire pad per pressure in the system. That can work for bigger cars that get a little heavier, as well as just more aggressive brake systems in general. That's why we generally go up in pad size the bigger a car is.
And then the other thing, going back to the beginning, the basics of hydraulics, you get an amplification force from your master cylinder to your corners. Yep. So the pressure is constant throughout the system, Pascal's law, but you have a certain diameter of piston inside your master cylinder, but at the corners, the area on those pistons is bigger and it amplifies that force accordingly. So you get a pressure amplification there.
And with the bigger pad size...
Force amplification, sorry, not pressure.
With the bigger pad size, you'll get a longer lasting pad because you don't have as much abrasion per pad unit area, and you'll get a little less heat produced because you'll have more surface area to dump the heat. Sorry if this is a little technical of a question, but you asked it in a little bit of a technical way. But bigger pads can dissipate more heat, and that's why they're generally on bigger cars that will produce more heat. So Rick
has his hand up.
Rick, who does?
Mike Nicola.
Nicola has his hand up.
Okay, so you want to open it up to Mike to speak, or?
Yeah, anyone who has their hand up, they can unmute themselves.
Yeah, if you have your hand, so Mike Nicolella has his hand up. If you want to unmute yourself, certainly ask a question.
They might have just hit it on accident.
Okay, you might have done it by accident. Okay.
We got one more question I saw from John, which is a really good point. Advanced Auto and other part stores have a free tool loaner service, such as twisting brake caliper compression tool, which saved me from having to buy one when doing Mini Cooper rear brakes. That's a great point. AutoZone, O'Reilly, Advanced often have a service where you make a deposit, let's say $100 or something, on a tool, and so long as you return it, you get that money back. I did that throughout college because I didn't have money to afford big expensive tools, and it's really useful because not everyone's going to need a spring compressor or certain specialty tools all the time, maybe just once or twice every few years, and that's a great recommendation for a tool loaner service from some of those places.
Any other questions we've got there that we may have missed? Noise in the background, a dog. Okay. Dog barking. So we have a dog with a question.
So I answered it in chat, but the penetrating fluid we recommended was a brand called Aerocroil. There we go. And we don't have it on us, but PB Blaster. PB Blaster can generally be found in any parts store or anything. Aerocroil.
Okay.
So Aerocroil, sorry about that, guys. Aerocroil is generally found online, but PB Blaster is can be found in a lot of parts stores and stuff, and is generally pretty easy to find. James Diamond had a question on speed bleeders. Great question. I'll grab those because you're hooked up to the mic. You can briefly touch.
Okay, so yeah, Aerocroil I really like. PB Blaster's not quite as good, but it's pretty good. PB Blaster was actually, interesting historical fact, developed by a guy in Cleveland, Ohio back in the 1950s, dealing with old rusty cars. He came up with his own home brew for dealing with old rusty bolts on old American cars back in the 50s, sold them out of the trunk of his car to mechanics at gas stations, and the rest is history. And it's a very closely guarded corporate secret, like the recipe for Coca-Cola. Having said that, there's an interesting article online in one of these, I think it was garagejournal.com, where this guy did a study with bolts that were rusted into threaded fittings, and he tried numerous lubricants to try to break things loose. And he measured how much force to break things loose. And he did it statistically correct multiple times. And so without any penetrating fluid, very hard to remove. With WD-40, slightly better, but not really much better. With PB Blaster, a lot better. With Aerocroil, even better than that. And then the best was this homebrew, which I also have, of transmission fluid and acetone 50/50. The only downside of that is it's kind of messy and it doesn't get very well into tight spaces. Whereas with an aerosol can, I can get it into a very tight spot.
Yep. So there was a question about speed bleeders. So here's a pretty popular speed bleeder in the BMW community. You basically fill this container. It's made by Motive. They make a lot of this product with different caps for your size of your reservoir. So you basically fill this container with fluid, tighten it onto the reservoir, and then you can pressurize it. And that'll act in place of your driver in the compartment for bleeding the brakes. I'm going to get out of the sun so my face doesn't blow out too much. I've used it in the past. Works great. You can pressurize the system and bleed it corner by corner by yourself pretty easily. I've done that before track days while on the lawn waiting to go up. You can do it pretty easily with them. Always worth a good check just to feel after the fact. And if all else fails, use your normal foot style bleeding method as a backup. But I've had good success with that, at least this particular speed bleeder.
Another option is you can replace your bleeders with one-way valves. You can find those online. So you can do it yourself too. So you can pump the pedal And then you have one-way valves at the corners that you crack open. Ethan, can you get a catch container out of that cabinet right there for brakes? So basically, this is what a catch container looks like here. And so basically, you've got this hose right here. You put it on your bleeder valve. So I've got a bleeder valve right here. I connect this to the bleeder valve. I've got a wrench here on the bleeder valve that I crack it open. This cable here, I can hang it somewhere underneath the car. And basically, this catches the used brake fluid. So as you're bleeding, you can watch the dirty fluid come in here, and then it'll get cleaner and cleaner as you get all the dirty fluid out of there. So this is a catch container, pretty easy to find online.
I think Maxine had a question. Maxine had a question. Do rotors need replaced when brake drums do?
When brake drums.
Maybe shoes and
Do pads? You're more of a drum guy. I don't like drums.
Yeah, so with a brake drum, if you have an older car with a brake drum, you're not measuring the thickness, you're measuring the diameter inside of here. And kind of the same as with a disc, as it wears, this diameter will slowly get bigger and bigger and bigger until it's too big. And then you've got to replace the drum. I think that's what the question is. And actually on these old Giuliettas, this is a cast iron liner inside of aluminum piece. I believe these liners are removable and replaceable, but somebody who's more of an expert would tell me that. But these do eventually wear out and you have to replace them. But it's not, but because it's contained inside, it doesn't really get the salt corrosion that rotors do.
Let me go ahead and grab it. John had a question about vacuum bleeders.
Vacuum bleeder. So we got a vacuum bleeder over here. Some people, it's kind of messy. Yeah, this is a vacuum bleeder. And so basically you can connect an air hose here to your air compressor. You turn this handle here and it creates a vacuum and you can suck fluid into here. I use this personally for draining master cylinder reservoirs. So when I'm flushing a system, I want to get all that dirty fluid out of the reservoir first. So I'll stick this sucker hose in there. I'll vacuum all the dirty fluid out of there. And then I'll put clean fluid in there and I'll start to bleed the system. I know a lot of people use these at the corners of the cars to bleed the system. I'm not a fan, particularly if I've got air in the system, because this always has air bubbles going on it. No matter what, you have air bubbles in the fluid, and it drives me crazy because I'm like, did I get all the air out of the system, or is this just the vacula? Because the vacula is finding every little pinhole and pulling air into it. And so I'm not a big fan of it, but certainly for sucking fluids out of reservoirs, it's a great tool.
I've used an inexpensive hand-actuated vacuum.
Oh, like a Mighty Vac.
It's from Harbor Freight. It costs $3. I've used that before in college. I can say it did not do a very good job. As you get towards like the nice vacula and stuff, it's a little nicer. But my best success with speed bleeders was the power bleeder that I showed.
Oh, the pressure bleeder. Yeah, I like pressure bleeders.
Tom Frasca raised his hand.
anyone who raised their hand, you can unmute yourself.
Yep.
Yep. Well, he used to run NAR. That's cool.
Okay, so what's the question?
Tom Frasca raised his hand. I don't know what the question is.
Okay, are we caught up on all the older questions? Have we?
I caught up on all of them. We have one question from B Munn in a second, but I was letting.
Well, I had my hand raised.
Here we go.
Question.
Question
So the
I
question
have.
I have is: so you say you have a problem on one corner, what do you recommend replacing on the other side? For example, I just bought an E24 that I can tell they refreshed much of the brake system, but one caliper on the rear needs to be replaced because it's still dragging.
Mhm.
So do you think it'd be worthwhile on a rear to do rotors on the other side? Or do you think, you know, because it is the rear, you know, just rotors and pads on the one side that was dragging?
So you have a bad caliper, but how are the pads and the rotors in general?
The pads and the rotors were all replaced not long ago.
Okay, but it still has a bad caliper.
It still has a bad caliper, and
I would just
debating
replace the
between
caliper.
rebuilding or replacing.
Leave the pads and the rotors alone unless they're unevenly worn. So check to see if those pads are evenly worn, And if they're evenly worn and there's plenty of pad left, I would just leave them alone and put on a replacement caliper.
I'd agree with that. I did that with the E30 once, and it ended up fine 40,000 miles later.
Yeah.
Hold the pads that probably come with the caliper as spares.
Yeah. Are you getting new pads, you said then?
Well, I'll probably get a preloaded caliper, so it'll have pads.
Preloaded caliper. Okay, then yeah, I would just keep them as spares. They're pretty fresh anyways.
Yeah.
The only thing I would be concerned about is, are they the same type of pads that are on the other side? Because if they're different pads with a different friction than the other side, you might have uneven braking in some pulls as you step on the brakes. So if anything, I would lean towards those original pads because they're the same as on the opposite corner.
Excellent. Thank you.
Yep.
Tom, did you have something?
Yeah, I did. Can you hear me?
Yes.
Yep.
Okay. Vintage Alfa Romeo, we only put, a very few miles on it a year.
Mm-hmm.
Question I have on the brake fluid and the moisture.
Yep.
Rather than bleeding the whole system, can you just replace the brake fluids in the reservoir? Use a .4, and will that eventually blend with the brake fluid to drop the moisture content?
The problem is that, so going back to engineering school, we're talking about diffusion. So
Right.
you got moisture containing fluid all throughout the system, and those steel brake lines that are running out to your corners, they're pretty small in diameter. So you're going to have fluid in each of your calipers or cylinders, depending on what kind of system you have, that are many feet away from the master cylinder. So even if you put fresh, dry fluid in the master cylinder, you still have wet fluid throughout the system. So, and you're not going to really dry the system out by having dry fluid in one part of the system. So really, that's why the pressure bleeders are so nice, is because they push the fresh fluid out through the pipes. So then the pipes and everything have clean fluid in it. Now, having said all that, if you have a lower, hardly used car at all, you use it only once in a blue moon, you can probably get away with 3, 4, 5 years without replacing. It's not picking up a whole lot of moisture just sitting in your garage.
Especially if it's an air-conditioned or relatively low humidity garage. If it's not,
Yeah, it is. And it's the single circuit Dunlop system. So whenever I bleed that, there always seems to be an issue. We've gravity bled it a few times initially when I got the car, and I hadn't really thought about moisture accumulation just sitting there. But I'm thinking, hell, it's going to be it's going to be the reservoir since the car has it's literally undriven except for.
Well, the other thing you could do, just as a chemist trick, to keep moisture out of the system, if you're going to leave it parked for months on end, what you can do on your reservoir is, first of all, there's a little pinhole on your reservoir cap.
Right.
It's like a little vent. Put a little piece of electrical tape on there, wrap some electrical tape around the cap itself, and you will actually probably keep the system very dry. I mean, those are where the moisture is coming in, is the threads on the cap as well as that vent hole.
Especially older systems with a non-one-way valve vent. You can also, for peace of mind, we've seen collectors do it. There's moisture measuring kits you can get, or electrical like tools that you can get to measure your moisture and see if you're below a certain percent. There's no concern, so you can keep running it, and you can test every year or two just to make sure you're not messing up the rest of your system and having to replace potentially very expensive wheel cylinders or bleed the entire system over again if you don't need to.
And by the way, those meters are used in Europe as part of their mandatory annual inspection. They literally measure the moisture content of your brake fluid, and they can pass or fail you on that. So it is a tool that's available out there for peace of mind.
Yeah, right now we're using a .4 fluid, and I think the last time that I completely, we rebuilt all the wheel cylinders, and it was probably about 4 years ago. And I hadn't really thought about moisture, intrusion, because again, the car has, so limited use.
Yep. And what part of the country do you live in?
We live in New York.
New York. Okay, you're going to get some humidity there then. It's not, if somebody was living in like Arizona or New Mexico, you're in great shape because of the dry air. But yeah, you're going to have some moisture in the air. But if you keep it in the garage and like I said, tape up that master cylinder when you're not driving it.
Yeah, I hadn't thought about taping it around the threaded portion. I did put a piece of tape over the vent hole.
Yep, that's a good idea.
Yeah, and especially with these single circuit Dunlop systems, you really want to have, everything on your side.
Yep, absolutely. Absolutely.
All right. Well, listen, thanks very much. Very interesting.
No
Great.
problem. Thank you.
Yep.
We had a question on brake-by-wire systems like in the new Alphas. That's a good question. Did you have any specific questions about them? Most of the systems I work on nowadays in new cars, all our modern Acuras run on them, and there are varying degrees of whether it's an electric booster or a full brake-by-wire. I know some of the new Alphas run brake-by-wire, and I can touch on those if you'd like, if you have a more specific question about it.
Okay, Maxine has a question. It looks like that maybe we missed. Sorry, typed wrong. When you replace the brake pads, do you need to replace the rotor? So to answer the question, it depends. So a mechanic or a do-it-yourselfer, when those pads come out, you need to check the visual condition of the rotors. Is there any pitting or scoring or gouges in it? If that's good, you need to check the thickness. If the thickness is in good shape compared to the legal limit, then you can probably get away with not replacing the rotors. So it depends. But if the rotor's in any bad shape at all, you usually just go ahead and replace it, unless they're the expensive rotors like Alex has, in which you might want to machine them.
Yep. Okay, so we got a clarification, and this is going to be a real fun answer. So the current system that I've seen in all brake-by-wire cars is a system by Bosch called EBB, Electric Brake Boost. You basically have, check to see where I look on the camera. There we go. So you have your brake pedal like normal, and you have a master cylinder like normal. And on the other side of the master cylinder is what's called an emulation computer. It's basically interpreting how much pressure you're getting and feeding back a small pressure to give brake feel. It's not real brake feel. It's more of a synthesized, computerized setup. I can say it is very good at making you think that everything is completely normal. And on the other end of this system, so completely disconnected, is your electricals over here that is actually activating brakes, actually using the brakes at all four corners. Is fade detectable? Yes. These are really good things. I've been a part of NSX testing on track, and it will absolutely show up that says brake system performance reduced, fade has been detected. This is through basically that electric system, not the system that you're touching, but the electric system is able to sense pressure differentials in the system different from normal. If your pressure has to raise more than it normally does to get the same amount of decel rate on the car, so the same amount of braking performance, it knows fade is occurring. It also has a model inside of it that predicts where the brake temps are at all four corners, because it knows how heavy the car is, how fast the car is, and how fast it's decelerating to zero, as well as the outside temperature. So it's a big system of equations that it's running to determine brake temperatures at all four corners. Fade's detected, and it compensates for that by bumping up the pressure. So these.
Oops, sorry.
It's a really good system, and to my knowledge, it's the same one used by Alfa, Chevrolet, some of the other Germans. I think the new BMW M8s have a similar system. I really like it, honestly. If you weren't told that it wasn't, you would think the brake pedal didn't feel completely normal, but it doesn't feel bad by any means. And for the performance benefits, it's really great. On track, you can hammer them all day long, and they'll give you feedback when your system's about to go bad, for lack of a better word. And it's allowed to be integrated into the car's VSA computer a little bit better to be even more stable and predictable on track.
Bernie Martin says that Tom Franco raised his hand.
We answered that.
We answered that. Okay, good. I just want to make sure we answered that. Since we brought up brake-by-wire, we didn't really cover it in this talk. We've covered it in previous webinars. Mercedes kind of pioneered brake-by-wire in the 2000s, but they had a lot of problems with the system too. So if anybody is like looking at a secondhand Mercedes from the 2000s and it has the brake-by-wire system, it's called SBC, I would stay away from it. But they are out there. It was a really cool technology for its time, but they hadn't worked out all the kinks. And now when you buy them, they actually had to extend their warranty on the car by 25 years. So if you have brake failure in 25 years, Mercedes will fix everything. It's a cool system, but a lot of failure problems with it. And I was exchanging emails with an owner of one of those cars who was asking me a lot of questions about it. And unfortunately, the dealers will not replace the system for you proactively. You got to wait till a warning light comes on your dash saying you've got a brake failure. Then you take it to the dealer. Then they fix it under warranty, but they're not going to do it preventively. So personally, I would just stay away from the cars if I was looking at that as a used car.
Another, I think I misread a little. The question, is fade detectable? By the driver, not so much, at least in the tunings that I've felt. It shows up on your instrument cluster screen of warning, brake fade imminent, brake system performance reduced, that sort of thing. So it's detectable via that, but your brake pedal feel is pretty consistent throughout. There is of course, a safety override system that if all the electronics fail, you still do have braking. It's like losing some of your brake booster assist where you'll get a heavy pedal, but you aren't just left to hang out and dry. You still have a mechanical system or a hydraulic system connecting you to the rest of the car.
So let me just say a few words about brake fade in traditional systems, because we really didn't touch upon that very much. So there's two ways that you can get brake fade out in the older cars outside of these new cars. And so one would be you're out in the mountains and you're driving down a long descent, and maybe you've got a trailer behind you. You got a lot of weight, and you're using those brakes quite a bit. Those brakes can get hotter and hotter and hotter, and then the brake fluid can start to boil inside the system, and you will feel that in the pedal. The pedal will suddenly become very squishy. It'll start traveling to the floor, and then you're in an oh crap moment because you've really lost a lot of braking effectiveness there. So that is traditional brake fade due to fluid boiling. The other type of brake fade I mentioned on the old drum brakes is, again, the shoes get super, super hot. They start gassing lots of material. You get a gas layer in between your friction material and your drum, and then your braking distances get much longer. You don't have as much friction as you used to have. So that's old style brake fade there. So in either way you tell it, because your braking efficiency is just suddenly gone because the brakes got too hot. What other questions? Do we have everything
I think we're
answered?
Up on the chat. I didn't see any when I went through.
Got it covered?
I think so.
Okay. Well, thank you everybody for attending. I hope you enjoyed it, and shoot me an email if you'd like a copy of the slides. I'd be happy to send them to you, and enjoyed presenting to you, and have a great day.
Thanks so much, guys.
Enjoy your cars.